All right, students. So now we're going to take a look at problem 6 on our sample final. So just reading the scenario first, it states the overhead reach distances of adult females are normally distributed with a mean of 202.5 centimeters and a standard deviation of 8.3 centimeters. Find the probability that the mean for 25 randomly selected distances is greater than 200.30. Okay, so when you read this problem, one thing to point out is that it states that the variable of interest, the overhead reach distances, is going to be your variable x, and we know that it's, again, normally distributed. So distance, by the way, is some sort of measurement. So normal distribution implies continuous data, which would then imply bell-shaped curve. So I want to do two examples here in this problem. So I'm going to do a part A and a part B. The correct solution to this problem is going to be from part B, but part A, I guess, gives us a little insight as to drawing the right situations. Okay. So underneath this problem, I wrote out some key notes regarding the Ti84 that you can use. So there are some important cases here. If you have an individual value x, you're using your normal CDF command, and if you're dealing with a sample mean, you're also using a normal CDF command, whether it's for a left, right, or between case. Now, the picture that you draw sort of helps you to see whether or not you have a left, right, or between case. And notice that the difference between individual values and sample means is that in the sample means, you have to compute a standard error. The standard error is just simply the standard deviation divided by the square root of n. Okay, so let's just assume that there was a part A and a part B. For the part A, we're looking at finding basically the probability of getting x is greater than, what was the value? 200.30. So if I want to draw this picture, first thing I note is my label of my axis. So for my horizontal axis, we can label it in terms of x, where x represents the overhead reaches. Now, at the center of your distribution is going to be the mean. So your mean is, in this problem, 202.5. All right, so I'm just going to write that on the side here. Mean is equal to 202.5. And we have a standard deviation of 8.3. Okay, now your value of x, which is 200.3, is a little bit smaller than this mean, right? So let me just rewrite the mean for us, so that way I could fit this. So the value of x that we have here is 200.3, and again, it's a little bit less than 202.5. So it's located to its left, or to the left of the mean. Now, if you look at my symbol for my inequality, let me just rewrite it. It involves the greater than symbol. So this means that I have a right case. Right? Greater than would imply right case. So I'm shading this right region. Now, if I want to find basically the area to the right of x equals 200.3, then I have to use the normal CDF command for individual values for the right case. So here it states that it will be normal CDF of the value of x, comma, basically nines repeating. You could use 8 nines in succession, followed by the mean, followed by standard deviation, right? So for us, our answer would be normal CDF of the value of x, 200.3, comma, nines repeating, followed by the mean, 202.5, followed by the standard deviation of 8.3. And I can enter this in my calculator and then round my answer to, let's say, 4 decimal places. Okay, so how do I do this now in the calculator? So it's second vars, normal CDF of 200.3, comma, the nines repeating, so I need to do 8 nines in succession, so that's 5 of them, 6, 7, 8, here we go, comma, 202.5, comma, 8.3. Close parentheses, and we're going to get an answer. The answer we get is approximately 0.6045. So that would be the solution if there was a part A that says if one overhead reach distance was selected at random, find the probability that that overhead reach would be 200.3 centimeters. And we got it based on our, we did our picture. From our picture, we picked one of the formulas. So we had to do the right case. And then we just entered the values into the calculator. All right, now let's actually do this for part B, which is the correct solution or the actual solution to what the problem was asking us. So here the problem now was asking us, find the probability that X bar, your sample mean, is going to be greater than 200.3 centimeters. Okay, so for this example, we're no longer dealing with X. X was the individual values. X was just the overhead reaches or individual overhead reaches. X bar, on the other hand, will be the appropriate way to scale or label our axis. So we have X bar, sample mean. How do I know, by the way, it's going to be a sample mean? In this problem, it says find the probability that the mean for 25 randomly selected distances is going to be greater than 200.3. So there's only two differences. One is the labeling. Instead of having X, we now have X bar, and you have a sample size. Okay, so what stays the same? Well, the value of the mean stays the same. It's still going to be 202.5. Right? Essentially, by the central limit theorem, what we have is the mean of the sample distributions is always equal to the mean of the population, right? So this mean is always going to be the same, population mean. Our sample mean, on the other hand, X bar, is 200.3. So let's say that's located here. And we still shade to the right. The standard deviation in this problem is still going to be 8.3, but now you have n is equal to 25, right? Because it says that, yeah, the mean for 25 randomly selected distances. All right, so for the sample mean, it involves using the standard error. So that's where you do the standard deviation divided by square root of n. So for part B, what our command should look like, just writing it on screen so you can see it, we have normal CDF of 200.3, comma, 8 nines in succession, followed by 202.5, followed by the standard deviation, 8.3, divided by the square root of n, which is 25. Okay, let me enter this now into our calculator and round it to 4 decimal places. So how do I do this? I hit second vars, normal CDF, so the second option. Enter the value of X first, 200.3, comma, 999s, repeating 8 times, comma, 202.5, comma, standard deviation 8.3 divided by, right? Make sure you put divided by second X squared to get your square root of 25. And you hit enter. If you round your answer to 4 decimal places now, you get 0.9075. Okay, so those are your solutions to parts A and B. If you're doing this using your, again, the graphing calculator, what I would suggest, my opinion to everyone is first make the image, right? Make a sketch, right? Even if you somehow make a mistake with the computation part, at least your professors can give you some partial credit for the sketch. Write out the command that you basically applying in the calculator, right? So normal CDF, yada yada yada, whatever needs to be inputted based on the rules, whether if it's a left, right, or between case. So I'm just going to zoom in if you ever want to pause the video, take a picture, or write this down. And then lastly, after you use the command, just make sure that when you get your final answers, just round it to maybe 3 or 4 decimals, right? In most cases, your professors would ask you to do 4 decimals. All right, that will be it for this problem.